Welcome to this Junior Cycle Higher Level Maths Revision video. This video is going to focus on distance, speed and time. In particular, we're going to look at using the formulae, average or mean speed, distance time graphs, and then finally look at some exam style questions.
So first of all, let us talk about the units that we use for speed. So you may know some already. We have different ones that we use in Ireland. We have kilometers per hour that we see on all our signs. Perhaps people at home talk about miles per hour, but kilometer should be the one that we're using. We're in the metric system. Anything we do calculation-wise will be in kilometers per hour. Or a second one which we see and you are probably familiar with from science is meters per second. So kilometers per hour, that's the one we see on all our signposts around Ireland. There are speed limits given in kilometers per hour. Meters per second, that is what we consider to be an SI unit in science. So this is what officially we should be measuring speed in. So let's talk a little bit about speed. So if I drive 120 kilometers and it takes me 2 hours, I can work from that then that on average it took me about 1 hour to complete 60 kilometers. So that effectively gives me the speed in kilometers per hour that I was driving at 60 kilometers per hour. And this gives us a formula to say, well, if I want to calculate speed, we take the distance and we divide it by time. If we talk about the unit, kilometers per hour, that per, when we talk about anything mathematical, means division. So if I said I wanted something per unit, we divide by the number of units. So per is going to be our division. So speed is equal to distance divided by time. In this question, we were traveling 60 kilometers per hour. Let's think about how then we can work out time. If I run 30 kilometers and I run at 6 kilometers per hour, then how long does it take me to run 30 kilometers? So I'm trying to work out time. I'm sure most of you can figure that out quite simply, that if we do 6 kilometers every hour, that would mean that there would take 5 full hours to run 30 kilometers. And that leads us to our next formula, and that is time is equal to distance divided by speed. So this would end up being 5 hours. So if I had never told you those two formulas, I think you still would have figured those questions out. And the last thing we're concerned about when we deal with distance, speed and time is, of course, distance. So if I run at 7 meters per second, now I've changed up my units here. So meters per second for 6 seconds, then how far have I run? Well, if you do 7 meters every second and you run for 6 seconds, then to calculate that, we're going to multiply the speed we ran by time. And that would give me 42 meters. So those formula are quite straightforward. Think about even the fact that we're talking about kilometers per hour, meters per second. That per has that division in there. I'll just explain here very quickly. Meters per second, you may also see written like this in science. That's got to do a little bit with indices that we'll see next year. But effectively what that means is meters divided by seconds. So here, when we have the idea of calculating speed, speed is meters, which is distance, divided by seconds, which is time, and that gives us our formula for speed. Then we're able to work from that to get the other formula. So we have three formula here. Distance is speed by time, time is distance divided by speed, and speed is distance divided by time. And they're all interrelated. And we use what's called a DST triangle to help us. So this is what it looks like. D is up the top, and then ST is down the bottom. That's why we call it DST, or distance, speed, time, sorry, DST triangle. So it says here you can use your thumb to cover the value you wish to find. For example, to find speed. So if you cover speed, so I'm just going to cross it out, you're left with distance over time. So that's distance divided by time, which is that formula there. If we wanted to work out the distance, we cover here, and S and T are beside each other, and there's a little multiplication there. And for the last one, for time, if I want to calculate time, I get distance over speed, distance divided by speed. So that triangle is really helpful. When you're doing any of your questions, I would advise you to draw out that triangle until you get more used to it. So one thing I want to talk about very early on, before we even look at an example, is the use of the word average or mean when it comes to speeds. So when we see questions about speed, we often see it called average or mean speed. Now, this doesn't mean you add and divide. So if you didn't cover statistics yet, mean is another word for average. You would have looked at average in primary school, and it's where you add all the numbers together and divide by the number of numbers. Now, when we have that word in front of speed, we're not going to do our traditional add and divide here. Effectively, the reason we cannot do that adding and dividing is because, unfortunately, it's not as straightforward as just assuming that all parts are going to be equally weighted. Okay, and we'll see a bit more about that in statistics next year. But the reason then that they put that word in front is because we are going to assume that in any situation there will have been a constant speed. And this is, of course, not what happens in real life. So if I said to you, the next time you're in the car, tell me what speed you're traveling. What you tell me is we travel at pretty much a different speed every moment that you get in the car. It is not moving. We then do something, it's called accelerating. We get faster. So the speeds are constantly changing. Maybe if you go on the motorway for a section, you might travel at a constant speed, but the speed is constantly changing. So we simplify our questions for junior cert, and for average and mean, they're just basically saying, if you had traveled the whole journey at the same speed, what would that one speed have been? So please be careful when you see that question not to do any kind of funny averaging that you may assume you should do. And like I said, this is why I'm talking about it now. Let's look at an example. So this has asked us for our average speed. And remember, that word average will just come along with speed, and we're not worried about it at all. So a train travels a journey of 210 kilometers in 2.5 hours. Find the train's speed. So we want speed. So I go over to my triangle. I want speed, and that is distance over time. So I write speed is equal to distance over time. And you can just use the letters. That's perfect. We have been given the distance is 210 kilometers. And the time is 2.5 hours. Therefore, speed is equal to 210 divided by 2.5, which you can put into your calculator. And that gives us 84 kilometers per hour. Now, the reason I know that my unit for speed here is kilometers per hour is because I put in kilometers and hours. So it's kind of like a machine. Whatever you put in, it's going to come out. If we put in meters and seconds, that's what would come out for our speed. Okay, try to keep it to either kilometers per hour or meters per second. The question will usually stick to one. Let's now look at a slightly more difficult question. So it's just not as straightforward. So a woman drives A woman drives 500 kilometers in 6 hours, and her average speed for the first 2 hours is 100 kilometers per hour. Find her average speed in kilometers per hour for the last 4 hours. Okay, so quite a difficult question. So let's figure out something. She has two sections. So the first section, or the first piece of her travel, it is where she has a speed of 100 kilometers per hour, and she has traveled we know the time it took was 2 hours, and therefore we can work out the distance she's traveled. In the second part of her journey, we don't know her speed. we know that the time will have been 4 hours because she traveled for a total of 6 hours, and we don't know the distance. So what we're going to do in this section here, we're going to work out using D is equal to speed by time. I'm going to work out that speed was 100 by 2, so the distance was 200 kilometers. So that is in the first section. So in that first 2 hours, she has traveled 200 kilometers. Remember, she drives a total of 500, so in the second section, she must have traveled 300 kilometers. Now, they've asked us to find her average speed for the last 4 hours. So speed is equal to distance divided by time, which is 300 divided by 4. And we can put that into the calculator, and that gives us 75 kilometers per hour. So we use the information that we're given. We should always think about our D, our S, and our T. We're usually given 2 pieces to work out the third, and we can work in questions like this where there are different sections to the question. So now let's look about units of speed. So what is 10 kilometers per hour in meters per second? So 10 kilometers per hour means that you travel 10 kilometers every hour. And bring it back to that. And I will always kind of bring back those units. And it makes a lot more sense thinking of it like that. So how far do you travel every hour in meters? So that means that we're going to travel 1,000 meters per kilometer. There's 10 kilometers. So that gives us 10,000 meters. So effectively what we're saying is we travel 10,000 meters every hour. But what about seconds? So we need to understand then how far do we travel every second. So in an hour, there are 60 minutes. In each minute, there are 60 seconds. So 60 multiplied by 60 gives me 3,600 seconds in an hour. So what I end up with is I travel 10,000 meters in 3,600 seconds. And effectively, I'm going to use what is speed is distance over time. That will give me my 10,000 meters all over 3,600 seconds, and that works out as they've given us 2.78 meters per second. So that's our step-by-step to convert. Let's look at another example. So I want to convert 18 kilometers per hour to meters per second, and then 10 meters per second to kilometers per hour. So just to remind us, 1 kilometer is 1,000 meters, and 1 hour is 60 seconds. 1 hour is 60 minutes. 60 minutes, each minute has 60 seconds, so 60 by 60 is 3,600 seconds. So when we want to go between kilometers per hour to meters per second, convert the meters. First convert the kilometers to meters, so meters per hour, then meters per second. Meters per second to kilometers per hour, we'll convert to the seconds first, and then we do the kilometers. So let's break it down and see if that makes sense. So if I say we have 18 kilometers per hour, that means we have 18,000 meters per hour. So we have 18,000 meters per hour, but 1 hour is 3,600 seconds, and therefore we can go to our calculator, put in 18,000 and divide by 3,600, which gives us 5 meters per second. So let's work the other way. We have 10 meters per second. So then if we want to think about per hour, we're going to say, well, if I do 10 meters in 1 second and there's 3,600 seconds in an hour, that will be 10 by 3,600, which is 36,000. And that's why if we're going from meters per second to kilometers per hour, so really the small units to the bigger units, we'll do the multiplication piece, so the seconds to hours first. So that is 3,600 meters per hour. So now I'm going to convert meters to kilometers. That involves division. So I have 36 kilometers per 1 hour. So that gives me 36 kilometers per hour. So a distance time graph, or known as a travel graph, is a special type of line graph used to describe a journey. The vertical, or the y-axis, represents the distance from a certain point, while the horizontal, or the x-axis, represents time. So here is an example. We can see that the time here is given in hours and the distance here is in kilometers. So it's showing us a return journey. So let's look at this journey in a little bit more detail. So this is a distance time graph of a cyclist who set out from town A. Note that both A and F represent the town. Now, that might seem a bit mad, but think about this. The y-axis, that distance, is the distance from the town. So the cyclist travels away from the town and then back to the town. So when he gets back and he touches that x-axis, that horizontal axis, he's back where he started. So note some things. From A to B, he cycled 20 kilometers in 1 hour. So here we have, and I'm going to try highlight as we go, along the time we have 1 hour and they traveled 20 kilometers. So therefore, you could then tell me really quickly his speed was 20 kilometers per hour. Here at B, he stopped for half an hour. So that's this section here where he was stopped. So a flat line is saying that he hasn't, in that time, changed his distance. So if you don't change your distance, you haven't moved. You're still the same distance away. So he must be stopped. So flat line on the graphs tell us that he's stopped. Oh, I've jumped ahead. At C, he took a lift on a lorry and he traveled to D at a distance of 40 kilometers. How we've worked that out, let me get my pen, is there's our 40 kilometers between 20 and 60, and he did that in half an hour. So there's halfway between 1 and 2. So that's 1.5 hours and 2 hours. So if you did 40 kilometers in half an hour, that would be 80 kilometers in an hour. So he was traveling at 80 kilometers an hour. And that's interesting. And you might have spotted something by now about this line graph that we talk about a lot. But I will talk about that in a sec. But just if you've seen anything interesting, just hold it. So he then rested for half an hour. So there's our flat piece again. He rested. That's the portion given by D to E. And finally, he took the train back to town. He had originally left and completed the 60-kilometer journey in half an hour. So 60 kilometers in half an hour. So that's 120 kilometers in an hour. So he was traveling 120 kilometers an hour. So we have this lovely graph that tells us a lot about a journey without having to give us any written information. Everything is displayed on the graph. Just be aware of some things. A change in steepness represents a change in speed. The steeper the line, the faster the speed. The flatter the line, the slower the speed. A horizontal line indicates a person or an object has stopped. And what we're talking about here is slope. So maybe you caught that. So if I ask you to calculate the slope of the line AB, that would be rise 20 over my run, which is 1. So my slope would be 20. But that's also my speed. So we get this lovely idea that speed on a graph is given by slope. Now, you're like, oh, mind blown. So this has no slope, it's flat, so it has no speed. Here we have rise, so 20 to 60, rise over run, which is a half. So you do 40 divided by a half, now be careful, which is 80. So that's 80 kilometers per hour. And then we have this idea here of this negative line. So we've had two positive lines and a negative line. And I'm not really sure what you see in science, but that has got to do with the idea that although speed is just a number, it has kind of a companion that's called velocity. And velocity is a vector, which just means that the plus or the minus, if I put it in front of a vector, tells us the direction. So the fact that the plus slope is going to, or sorry, away from town A, then the negative slope is coming back to town A. So that positive or negative is actually telling us a direction. So I don't know how much of that you see. I think you use the word velocity anyway in science. Velocity and speed are pretty similar, and we don't have to worry too much about the differences. But if you're wondering about why is one slope positive and one slope negative, positive is going one direction, negative is then coming back. It's going the opposite direction. And we have that idea in maths already. If you have a number line and I say add, you move to the right. If I say subtract, you move to the left. So we already have this idea of plus going one way, minus going another, but we may not talk about it explicitly. So example 1. A helicopter leaves Shannon at 9:30 a.m. and arrives in Limerick at 9:45 a.m. the same morning. It travels 25 kilometers during this journey. Find its mean speed on the journey in kilometers per hour. Okay, so some really interesting things happen here. They haven't given us the time, we have to work it out ourselves. So we have 9:45 minus 9:30, which tells us that it was 15 minutes. So we have time equals to 15 minutes. They've given us the distance, which is 25 kilometers, and then they've asked us to find the mean speed, which we know is just speed, but they want it in kilometers per hour. So I'm going to draw out my little distance, speed, and time triangle. It looks like this. I want speed. Speed is equal to distance over time. Now, my issue at the moment is my units don't match. So I've been asked to do kilometers per hour and the kilometers match, but per hour I actually have minutes. So I need to convert the minutes I have into an hour. So if it helps, use your clock to figure out 15 minutes. So if you said it was 15 minutes past an hour, you would say generally that that was a quarter past. So 15 minutes is a quarter. If you didn't know that, we would put the number of minutes over the number of minutes in an hour, which is 60, and simplify. So that gives me a quarter, or if you prefer to work with decimals, 0.25. It might be easier to work with decimals since we're talking about a fraction. So my speed is distance divided by time, 0.25, and that will give me 100 kilometers per hour. Now, did we have to use that method? Well, some of you might have spotted, well, if it takes you 15 minutes to go 25 kilometers, then you do 4 of those 25-kilometer journeys in an hour, which would mean that you would have traveled 100 kilometers in an hour, which would give you the speed of 100 kilometers per hour. And that would also be perfectly correct as long as you showed all your work. So the second question. Mary is planning to fly to Heathrow. The table shows flights leaving from Dublin Airport and arriving at London Heathrow on a particular day. Mary needs to arrive in London Heathrow by 10:30 a.m. What is the departure time of the latest flight she can get? So she needs to be in Heathrow at 10:30, which sits in here. So that's where she wants to arrive. So the latest flight she can take leaves at 8:50 a.m. But it is given in 24-hour clock, so 0850 is perfect. If you prefer, you can write 8:50 a.m. So what is the time of her flights in hours and minutes? So we have 10:15 subtract 8:50. Now, can't do that, so I need to borrow an hour. So this goes down to 9 and we add 60 on here. Now, it doesn't matter how you add on 60. I'm going to change this to 75. So effectively what I have is 975 minus 850. And when I do that, we get 25, so we get 1 hour and 25 minutes. These are not decimal points. So Mary would like to arrive at the airport 75 minutes before that flight leaves. At what time should she arrive to the airport? So I like to work in hours and minutes. So 75 minutes, that is equal to 1 hour and 15 minutes. So the flight departs at 8:50. So we're going to take away 1 hour and 15 minutes. So when we do that, we get 7:35. You can write in 24-hour or you can write 7:35 a.m. So that's a little bit of work with our time. So example 3, Lewis is driving at 90 kilometers per hour when he sneezes. During this sneeze, his eyes were closed for half a second. Work out how many meters he traveled in this time. So this was a higher level question, and although quite short, there's quite a lot in it. So let's take out what we know. Our speed is 90 kilometers per hour. However, they're talking about seconds and meters. So the first thing we're going to do is we're going to convert. So I like to write it like this. We have 90 kilometers per 1 hour. When we then change it, I'll change this to meters and 1 hour to 3,600 seconds. And this will end up giving me the correct answer. Now, I did show you kind of another way to go about that yesterday, but this is just a different way you can do it. This is how I would do it, even up to the Leaving Cert questions, because I think it's the easiest way to visualize it. For me, this idea kilometers per hour. We did the exact same steps yesterday, we've just approached it slightly different. So now we know that Lewis is actually driving at 25 meters per second. So every second he'll travel 25 meters. Now he's closed for half a second. So I'm going to use the DST triangle here. If you're kind of going, oh sure, I already know the answer, that's brilliant. But just in case you are stuck, we are trying to figure out the distance, which is speed multiplied by time. So the distance is 25 multiplied by now the time. So that is my that's my speed. And my time was half a second. It can help to use decimal just from a calculator point of view. I'm not a big decimal fan, but if it's a nice easy decimal like that and you can put it into your calculator, absolutely perfect. So 0.5. So the distance he travels while he sneezes is 12.5 meters. So actually not a bad question, but there was a lot in that. It wasn't just as straightforward. You put it into distance, speed, time, the DST formulas, and it just works. So this is kind of where we're aiming to get to, this kind of question.